So like I said, we are starting on the third quarter topics. And the third quarter in science is all about motion. So we are going to learn all about physics. And the specific topic is about motion. So when we say motion, of course, it's related to the idea of movement, of changing from one place to another place, the difference between the initial location or the starting point and the final location, okay, or your endpoint location. Okay, so specifically for today, what we will learn about is the difference between distance and displacement. So there are other measurements of motion, pero for today, we will focus on motion in terms of distance and displacement. And then for the following weeks, we will learn about motion in terms of speed, velocity, and acceleration. Okay, and then let's continue. For today, this is our essential question. So later on at the end of our discussion, we will be answering the following essential questions. So the first one is, what is the difference between vectors and scalar quantities? And then the second essential question is, what is the difference between distance and displacement? Again, we are going to learn 4 new terms or concepts for today. The first one is in terms of quantities, vectors and scalar quantities. And the second one is in terms of motion, specifically about distance and displacement. Okay, so first let's learn about what is a scalar quantity. So it says here on the definition that scalar quantities are actually measured in terms of numbers and units. So you have to remember, in physics, number alone is not enough. A quantity, a scalar quantity, has to have both numbers and units. Okay? Kasi in mathematics, most of you are familiar with computation ng numbers lang. So for example, 1 plus 1 is equals to 2 in mathematics. But in physics, that's actually not considered as a complete measurement. It has to be with a unit. For example, it's 1 centimeter, and you're going to add another 1 centimeter, so you come up with 2 centimeters. So yung centimeter na yon is what we call as the unit of measurement. And very important in physics na lahat ng answers ninyo should have the number and the unit of measurement. I know si Teacher Daisy nag-discuss na about the different units of measurement. As far as I remember, she already taught you how to convert measurements, for example, from inch to centimeter, from centimeter to millimeters, from meter to millimeters. Tama ba ako? Naituro na ni Teacher Daisy? Okay, so may nakikita akong mga nagnanod.
Sir Bernard po.
Si Sir Bernard ba? Okay, si Teacher Daisy din kasi nagtuturo ng topic na yon under TLE. Kasi, for example, baking, yung ibang recipe ang binibigay sa inyo, magkakaibang units of measurement. So, dapat marunong tayong mag-convert from one unit of measurement to another. Okay, so again, very important in physics, itong tinatawag nating units of measurement. So what are scalar quantities? So sabi niya dito, scalar quantities must have numbers and units. So for example, in terms of length or yung haba, we usually have, example, 16 centimeters. So if you will notice, meron siyang number which is the 16, and then meron siyang unit which is your centimeter. So this length is measurable by a scalar quantity. For example, yung isang ruler ninyo, 1 foot rule is equivalent to 12 inches. Okay? So, yung isang ruler, yung mahabang ruler, hindi yung kalahati. 1 foot rule is equivalent to 12 inches. So, that is a scalar quantity. You have the number 12 and you have the unit inches. Okay? So, that is a scalar quantity. Another example of a scalar quantity is what we call as temperature. Okay, so there are 3 units of measurement for temperature. We have centigrade, Fahrenheit, at saka yung degree Kelvin. So most commonly in the Philippines, our unit of measurement for temperature is in terms of centigrade. Okay, so for example here, the measurement here is around 101.5 degrees centigrade, or rounded off to 102 degree centigrade. Okay, in other countries, they use different units of measurement. But as you can see, there is a number here and there is a unit of measurement. So this is another example of a scalar quantity. Another thing that we can measure in terms of scalar quantity is what we call as time. So for example, how long do you usually take a shower? If you take around 30 minutes to take a shower in the morning, so that is a scalar quantity because may number siya, yung 30, and ang unit of measurement niya is in terms of minutes. You can also use hours and seconds as a unit of measurement for time. Okay, so these are all examples of scalar quantities. Okay, do we have a question? Or okay pa tayo? Is everything clear?
Yes.
Yes, okay. So I have a question. If I want to measure weight, yung bigat, okay, I want to measure the weight, is that a scalar quantity?
Yes.
Yes, so si Prince tumatanong,
Yes.
sabi niya, yes, weight is a scalar quantity. So can you give me an example of a measurement of weight?
Kilograms.
Specific kuya, with number.
7 kilograms.
Okay, 7 kilograms. So
75 pounds.
75 pounds is another scalar quantity for weight. What else?
5 pounds.
British though.
Diba? We have tons or tonelada. Okay, so pounds and kilograms are common forms of measuring weight. If you are baking, you can also use grams. Diba? For example, they will ask you to add 3 grams of flour, like that. Okay, so those are scalar quantities for weight. How about volume? Is volume a scalar quantity?
Yes.
Yes.
Yes. Okay, so can you give me an example of a scalar measurement for volume? Do we have example? For example, this water bottle contains
2 cups.
2 cups of, or for example here, it contains 500 milliliters of tawag dito, water. Or for example, you bought a 1.5 liter of Coke. So 1.5 liter is a scalar measurement for volume. You have the number 1.5 and the unit of measurement is in terms of liters. Okay, so all of those are scalar quantities. So are we clear about scalar quantities? But thumbs up ako if you have questions or walang question. Okay, thank you very much. Now let's go to the next one. And this is what we call as a vector quantity. So kung yung scalar quantity natin focuses only on the number and the unit, vector quantities are measured with numbers and units also. But for vector quantity, we also need to have what we call as direction. So for scalar quantities, it's only the number and the unit. But for the vector quantities, we are going to use number, unit, and of course, the direction. So for direction, we have the idea of north, east, south, and west. If you want to be very specific, you can include yung northeast or southeast,
Southeast.
something like that. Northwest, southwest
Northwest.
directions. Or you can be very general in terms of your direction. You can just go up and down. Okay, upward force or downward force, upward
Left and
movement
right.
or downward movement. So these are examples of vector quantities. So sabi niya dito, acceleration is actually a vector quantity. For example, this rocket ship is accelerating at 30 meter per second squared. Okay, so of course, your rocket ship, the movement of the rocket ship is going upwards, as you can see here in the picture. So this one is already a vector because it has the number, which is the 30. You have the unit for acceleration, which is meter per second squared. And then, of course, we have the direction, which is going upward. Okay, the same here when it comes to displacement. It says here displacement is 200 miles northwest. So we have the number 200. We have the unit for displacement or distance, which is miles. And then we have the direction, which is northwest. And then here on the last picture, we have the idea of force. Force is a vector quantity. So for example here, the force acting on the apple is 2 newtons. And of course, because gravity is acting on this apple, the movement or the direction of the movement of the apple is going downwards. Okay, so this is 2 newton downwards. Kaya pagka bumagsak na yung apple, tatama siya dun sa ulo ng tao. Kasi ang force na nag-a-act doon sa apple is the gravity pulling the apple downwards to the center of the earth. Okay? So this is a vector quantity. So again, we have to remember, for scalar quantities, we are only focusing on the number and the unit. Pero for vector quantities, we are focusing on the number, unit, but also with direction. Is that clear? Or do we have questions?
Wala po.
Okay, thank you very much. So now let's go specifically to our measurement of motion, which is our distance and displacement. So distance is actually a scalar quantity. So ibig sabihin, when we measure distance, we are only using the number with a unit. Whereas displacement, as you can see here in the example, is a vector quantity. So later on, we will see that a displacement must have not just the number and the unit, but also the direction. Okay, so now let's start with distance. So sabi niya dito, distance, short, small letter D, okay, is basically how far an object travels. Okay, so gaano kalayo yung na-travel niya. So in order to measure distance, we need to have a starting point and an end point. So starting point, for example, here, if you will see the ant, the starting point is around 0 centimeter. And then later on, to measure the distance, we need to check what is the end point of this ant. So for example, imagine that this ant is crawling along a ruler. So this is a ruler. The unit of measurement is in terms of centimeter. For example, the ant will crawl and it will end here. So our starting point is at 0 centimeters and our ending point is at, what's the end point?
3 centimeter.
Thank you very much. 3 centimeters. So now we are going to measure what is the distance or how much distance did the ant travel from the starting point going to the end point. Yes, Yuri.
3 or 4.
3?
4 centimeters.
What's your final answer, Kuya Yuri?
3 centimeters, sir.
Thank you very much, Yuri. So yes, the final answer is 3 centimeters. Okay, so how did we come up with that? So basically, you just add the starting point, which is 0 centimeter. You're going to add that to the end point, which is 3 centimeter, so that you come up with the total distance traveled of 3 centimeters. So again, very important that you include the unit centimeter in your answer because we are talking about vector quantities. Okay? So it doesn't matter, sabi niya dito, in which direction will the ant crawl? As long as you measure gaano kalayo yung na-travel niya, regardless of the direction, because distance is a scalar quantity. Okay? Okay ba tayo dito sa distance? Let's continue to the next slide. Okay. So for example, from the 3 centimeters, the ant did not stop moving. For example, it continued to move from this 3 centimeters going back to its original starting point, which is the 0 centimeter. So now, what is the distance traveled by the ant? Originally from 0, it went to 3 centimeters. And then from here, it went back to this original location. So now, what is the distance traveled?
Ano sir, sa start
Centimeter?
nag-travel siya 3 centimeter, pero nung pabalik siya, sir, 3 centimeter ulit. In total, 6 centimeters ang na-travel niya, sir.
Okay, thank you very much. Okay, so now that his direction changed, of course, nag-change din yung kanyang distance. Okay, so sabi nyo nga, if we're going to count 1, 2, 3, 4, 5, 6. So the total distance traveled now by the ant is already 6 centimeters, regardless of the direction. Okay? Okay, so for example here, the ant moved here, and then it stopped here. What is the distance traveled by the ant?
8 centimeter.
Thank you very much, Kuya Gian. So the total distance traveled by the ant is 8 centimeters. So from 0, it went to 5, and then from 5, it went back and stopped at 3. So that's 0 centimeter. You're going to add 5 centimeters, and then you're going to add an additional 3 centimeters. So the total now is 1, 2, 3, 4, 5, 6,
6, 7. 7 lang, Char.
centimeters. Okay, 7 centimeters ang kanyang distance traveled. Okay? Questions when it comes to this distance?
Wala na
No.
po, Char.
But
Now,
it's actually a
with displacement. Yes, Reynald?
it's actually vector from earlier where when it actually showed the map of United Kingdom and Ireland.
Okay, thank you, Reynald. So now let's focus on displacement. So by definition, displacement is the distance between an object's final position and its starting position. So earlier on, what you were doing is just adding up the distance traveled by the ant. But this time for displacement, it says here that it's the difference. So we are now starting to subtract. And what are we going to subtract? We're going to subtract the final position from the starting position. Okay? Kanina, di ba, nag-a-add lang tayo. So you have to remember that by definition, displacement is the difference between the final and the starting position. Okay? And because displacement is a vector quantity, it means that it depends on the direction of the motion. Okay? So by equation, we come up with this displacement by subtracting the final and the initial position. So this is the equation for displacement. So distance, the final distance, subtracted by the initial distance. And yes, we do need direction. So for example, units of direction can be as simple or as general as a positive and negative. So for example, if the motion is going upwards, then that is a positive direction. If the motion is going downwards, then that is a negative motion or negative direction. Also, we use the different directions north, south, east, and west. Okay, so generally north is a positive direction, south is a negative direction, east is a positive direction, and west is a negative direction. Okay, if you will go back to the idea of your Cartesian plane, same lang din yung idea nila. So for example, this is your Cartesian plane, right? So this is your east, this is your north, this is your west, and this is your south. So again, your north is going up, so this is a positive direction. South is going down, so this is a negative direction. East is a positive direction, and west is a negative direction. Okay? So yung sa Cartesian plane ninyo, pag northeast, pareho siyang, pag nasa first quadrant siya, parehong positive yung values, di ba? Pag nasa second quadrant, it's a positive and negative values. Pag nasa third quadrant, yun yung parehong negative yung values. And then nasa fourth quadrant, it's a negative, positive value. So same lang din ang idea pagdating sa math. Okay? Now let's continue with the idea of displacement. So the example of distance is this. The ant walked 3 centimeters. Again, we don't know what direction the ant is moving as long as the ant covered a total distance of 3 centimeters. Okay? But an example of displacement is the ant walked 3 centimeters to the east. So this time, the movement of the ant is indicated na in which direction is the ant.
Positive.
Yes, so this is a positive 3 centimeters if we're going to change yung direction, yung east. Okay? Awesome. So you have to remember that the object's distance traveled is not the same as its displacement. Okay? Kasi nga, may direction siya. And later on, I will give a specific example on how we can come up with different values for the total distance traveled and how is it different with the displacement of the object. Okay, so for example here, let's go back to the ant, the traveling ant or the crawling ant along the ruler. Okay, so for example, this is the movement of the ant. So it traveled from this starting point to this end point. So it's a positive movement, okay, going to the east. So we can say that the distance of this ant is 3 centimeters. But in terms of displacement, we can say that this is a positive 3 centimeter or the ant traveled 3 centimeters to the east. So in that case, pareho pa yung distance at saka yung displacement niya. Okay, so distance is 3 centimeters. Ang displacement niya ay positive 3 centimeters or 3 centimeters to the east. Malinaw pa tayo doon? Okay, so now let's continue.
Pwede hindi na pala sabihin yung is, lagyan na lang ng positive?
Yes, it's okay if you don't, whichever unit of direction you will be using. Okay? And then, let's continue. From this 3 centimeters distance, the ant continued to move again. And it went back to its original starting point. So what is the total distance traveled of the ant? In this case.
Sure.
Yes,
It's
sorry.
centimeters.
Distance muna tayo ha. What is the distance traveled by the ant? Diba? Una,
3 centimeters.
wait lang. Nagsimula siya sa 0, diba? And then it went here. And then from here, it went back. So ano daw ang distance traveled niya?
Sure.
3 centimeters.
6 centimeters.
Okay, so 6 na siya. 3 kung starting point niya dito, pero kung i-count natin yung first movement ng ant, then it's already 6 centimeters. So in this case, kung starting here, that's 3 centimeters, ang magiging displacement niya ay
Negative 3 centimeters.
thank you very much. Negative 3 centimeters.
Close to 0.
Yes. Okay, so now, ito na yung movement niya. Nagpunta siya ng 5. And then it stopped at 3. So what is the distance traveled by the
Nag-travel siya sa...
7.
7 what?
Centimeters. 7 centimeters.
Okay, remember, scalar quantity, hindi pwedeng 7 lang ha. We need to include the unit. So it's 7 centimeters. Now, what is the displacement of the ant?
Sure. So, nung nag-travel siya sa east, positive 5 centimeters, sure. Nung bumalik siya, negative 3 centimeters ang na-travel niya, sir.
So what is the displacement?
Positive 7 centimeters. Because the 5 is bigger.
Ang tawag dito, what is the equation for displacement?
Sure. Negative 7 centimeters.
What first, answer the question. What is the equation for displacement?
Final position minus initial distances.
Okay, so now,
Gets
the final
wala.
position.
Positive 3 centimeters.
Okay, and then what is the initial? What's the initial location? Or what's the initial measurement? Initial distance. Tama si Kadesh doon sa final. So, this is displacement. So, this is a positive 3 centimeters. Ay! Nasaan ba yung aking ballpen? Positive 3 centimeters minus, what's the initial measurement? Saan tayo nagsimula?
Sa 0.
Okay, 0 centimeters. Therefore, our displacement is
3 centimeters.
thank you very much. So that is the displacement. So distance is 7 centimeters, pero ang ating displacement ay positive 3 centimeter. Okay, sorry, nagkamali ako. Walang positive yung displacement ko. Displacement is a vector quantity. So it's a positive 3 centimeters. Okay? So I know medyo nalilito pa yung iba. I have less than 1